Hi guys, welcome to my second video on titration, and today's video we're going to be looking at titration in different kinds of form, different solving we're going to be doing. And so in this problem we are asked to solve for the concentration into value, and it says here the following table shows the Boer reading obtained when 25.0 cm³ of a solution trioxocarbonate of 4 containing 1.30 gram in 250 cm³ of solution was titrated against a solution of hydrochloric acid of an unknown concentration. So they are asking you to calculate. Now we have few questions that they give us. This is the whole summary of the question. We have to get our numbers from here. Remember those numbers I was giving them. They give us mass of sodium carbonate, they give us volume of sodium carbonate, volume of the solution, the volumetric flask in which they use to measure the volume of the two compound. Where's the two compound involved? The two compound involved in our problem here are hydrochloric acid and sodium carbonate. So the next question is saying we should copy it and complete the table. And question 2 is saying calculate the average volume of the acid, and then we have write a balanced equation for the reaction in the titration. And then the next question is saying from the information obtained above, calculate the concentration of sodium carbonate in mole per dm³. Then the second question is saying we should be able to calculate the concentration of the hydrochloric acid in mole per dm³ also. So what we're going to do in this case, it means that we'll first start with the first question. It says copy and complete the table. So here's the way the table is looking on the exam. On the exam, you want to see the table like this. You have empty tables, and they're asking you to copy and complete those tables, those blank spaces. Here you have rough reading 1 and 2. This is basically the amount of time in which they did this titration, and you have red final reading, initial, volume. And so we're going to look at them. I have a very simple way of doing this. So in our chart, to answer the first question that says copy and complete the table, so what we're going to do in answering this, we're going to minus 23.50 minus 20.00. We're going to get 21.50, and to get the final reading, we're going to add 23.50 plus 20.70. we're going to get 44.20. And so the next thing we're going to do, minus this value and this value, which is 25.20 minus 20.90, we're going to get here. In this chart, remember this, I want to tell you that we minus in, but we don't put negative number in here. So maybe probably you took big number from small number and you got negative number, you just take the negative away and put positive numbers in here. And so remember, in finding final reading, we're going to add two numbers to get final. In finding initial, we're going to minus two numbers to get initial. In finding the volume, we're going to minus these two numbers to get volume. So that's very clear. The next question is saying we should calculate our average titration. So in calculating average titration, we should take into consideration the volume acid. Only this number here we're going to be using in our volume acid. But in looking at it, you're going to know the lesser number here. Maximum number should be 0.1, 0.2, like that. If you look at this number here, 21.50 minus from this, you get bigger number than if you minus this from this. So we're going to take these two numbers, 20.70 minus 20, just a little minimum, maybe 0.1 or something. So we're going to take 20.70 plus 20.90 as our real value in this case. So in this case, it means that we're going to say that 20.70 plus 20.90 divided by 2, because we took two numbers. If we are taking 3 number, we're going to divide by 3, but in this case we took 2, so we're going to divide by 2, and if you add them and divide by 2, you're going to get 20.80 cm³. This obviously becomes our average volume. Then our average volume. If you do this, the next question we're going to move to is is we were asked to write the balanced chemical equation of the reaction. In writing the balanced chemical equation, what we're going to do in this case, the reaction is between sodium carbonate and hydrochloric acid. So you first write sodium carbonate and hydrochloric acid. If you change, leaving this one, take this and put this here, you're going to get NaCl here. And if you change your hydrogen here, you're going to get carbonic acid. If this carbonic acid dissociate, you're going to get water and carbon dioxide. So in this case, you're going to get this reaction. This reaction become neutralization reaction. In my last video, I did this reaction. You can check on my page. So if you see, it means that sodium carbonate here becomes our base and hydrochloric acid becomes our acid, and then our mole of sodium carbonate here is 1, and our mole of hydrochloric acid here is 2. So we got 2 here and we got 1. This become, in our next solving, we're going to use this value. That's the reason I'm laying more emphasis on this value. The next thing we're going to do, we'll only ask, so in this case they just ask us to find to write our balanced chemical equation. So we already read our balanced chemical equation. The next thing we're going to do is to calculate the concentration of sodium carbonate in mole per dm³. So in calculating the concentration of sodium carbonate, we're going to use the molarity formula. So the first thing we're going to do is we're going to first convert the volume of the sodium carbonate to dm³, which is 25.0 cm³ to dm³. So in normally we know that 1 dm³ is equals to 1000 cm³, and if we do this math here, it means that we're going to divide 25.0 by 1000, and we're going to get 0.25 dm³ as our converted value in this case. So after that, we're going to use our molarity formula. Molarity is mass or molar mass and volume in this case. So in this case, we're going to say concentration of sodium carbonate will be equals to the mass over molar mass or times volume. So if we do this, the mass given us from the problem, from our initial question, was 1.30 gram, and the molar mass normally from this compound is 106 sodium carbonate, and I did this in my last video. So we're going to times it by the converted value of the volume of sodium carbonate. So we're going to keep this 1.30 gram and gram going to cancel. 106 times this, we're going to get 26.50. If we divide 1.30 divided by 26.5, we're going to get the concentration as 0.0491 mole per dm³. This becomes the concentration of sodium carbonate. Our next question is asking us to calculate the concentration of the hydrochloric acid in mole per dm³. Similarly, we're going to do, but we're going to use, in this case, we're going to use the titration formula in calculating the concentration of the hydrochloric acid in mole per dm³. So in doing this, we're going to get, we're going to say that from the reaction, the mole of the acid was 2 and the mole of the base was 1. We have to know this first, because we don't want to forget. We're going to use it. So our titration formula is normally Ca times Va divided by Cb times Vb. What is C? C in this case is the concentration and V is the volume, equals to the number of mole of A divided by the number of mole of B. We always use this formula to calculate to do calculation in our titration. This formula is, in my last video I discussed this. I told you this is the titration formula. So Ca will be equals to Cb times Vb times NaN. They want to divide by Va times Nb. So we do this. Previously, the concentration of the base that we solved previously using our molarity formula was 0.0491 mole per dm³. So we're going to times it by the volume of the acid here, which by the volume of the base, which is 25.0 cm³. The converted volume, we're going to use the raw volume from the problem given in this case. Before we converted 25.0 CMQ to DMQ, but now we're not using the converted one, but we are using the raw because we want for CMQ and CMQ to cancel. So we're going to use 25.0 CMQ times by the mole of the assay that is given here, divided by the average volume. You remember the second question was calculate the average volume, and so in calculating the average volume automatically becomes the volume of the assay in this case, in this reaction. So we don't want we can use any other volume, but we're always going to use the average volume, and the average volume was 20.80 CMQ times the mole of the base. So if we times everything here, 0.04925 times 2, we're going to get 2.455. 28.80 times 1, we're going to get 20.80. If we divide these two numbers, if we divide 20.455 divided by 20.80, therefore our concentration of the hydrochloric acid will be 0.118 mole per DMQ in this case. So if we do the same, we answer our question. Just one question. This just one question. Thank you for watching. See you in my next video. Bye bye.